what we would say in classical physics is that there is a determinability of the object as it moves or progresses through time. So there's no definition of what f of x is, because if there is some definition about the outcome of the black box that we're describing, then that's necessarily deterministic. So the brain is just like a physical object, right? And the brain is what is giving us the capacity or the information about the universe around it. And I would posit that it's most likely the case the brain can only be parameterized or permutated or constructed in a limited set of ways in order to provide an understanding of information about the universe. And outside of that limitation of what the brain is able to be constructed into, exists a lot of the functionality, or I would say the vast majority of functionality that exists within the universe. All right. So I'm going to talk about, I think, the two big takeaways of quantum mechanics that, if we're going to be using philosophical arguments in relation to what we understand about quantum mechanics, these are kind of the two important takeaways that we should be using, and we should use them carefully, because I think anyone who wants to use quantum mechanics to justify some philosophical perspective about reality needs to be extremely careful because of how new the field is, and then also because a lot of what, like, if you're not an expert in the field, then the assumptions that you're making or kind of your understanding of how quantum mechanics is described may be incorrect. And as a result of that, there's assumptions that you might make philosophically that aren't actually held true from the observations or from the documentation that we've created of quantum mechanics. So from my perspective, I think that I do fall into the category of more of a layman, but maybe a slightly more educated layman. So quantum mechanics is something that I've learned about in college, but in addition to that, I love learning about physics, and I love learning about how the universe works on a very fundamental level. And so I've done a lot of, I'm going to say, light research on quantum mechanics, in that, I've watched a lot of YouTube videos about it. I've read a few papers about it, and I think that I have a decent grasp of the kind of basic understandings that a layman should have of quantum mechanics. Now, the more complicated sides of it and the interpretations of the observations that we make within quantum mechanics, I think that a lot of those details would require someone who's a lot more knowledgeable, because it could be that, maybe even in this video, in my assumptions, what I'm pulling out of the statements that others have made about it or from the data that we see about it, I'm pulling out an assumption that with, a higher understanding of quantum mechanics would easily be disproven or would be indicated as not pointing to what I'm assuming it's pointing to, right? But with all that said, I think that there is some legitimacy to talking about quantum mechanics with respect to our philosophies, just because, it is the latest, hottest understanding of how the lowest level that we can perceive works within our reality. And so it would be, I think it's just like, it's like we want to use it, if we're going to be building philosophies that describe all of reality, then it seems pretty important to include what we're observing in quantum mechanics into that, even though we're probably limited in our expertise in being able to properly kind of encompass what quantum mechanics is telling us. But I'm going to attempt to do my best to kind of get the core things that we should be taking out of it, and then beyond those core things, we shouldn't be assuming more than that. So the first thing that I think that we should be taking out of quantum mechanics is that there appears to be, from our observations, an undeterminability at the lowest level that we can observe. And when I say lowest level, I don't mean lowest level of like anything possible in the universe. So, I'm not talking about quantum mechanics as like the prime mover, as like the fundamental object at the bottom of the universe that's causing things to happen. Rather, I think that from our perspective, from the observations that we have about reality, that's currently just really the lowest level understanding that we have about how reality is constructed. So the first thing like I was saying, is the undeterminability. So in a traditional physical system, when we think of physics, even up to general relativity with Albert Einstein, we have a determinability of a system given we have the information about the system, right? So let's say we have some system and we know the facts about that system. So let's say our system is like two bodies orbiting one another out in space, right? And this box here is just the information present within this system here. And from this information, let's say we have some divine perspective that gives us all of the physical information about the system that we're describing here. What we would say in classical physics is that there is a determinability of the object as it moves or progresses through time. And so that is to say, we have a set of equations, or this arrow here that's indicating the movement of the rock can be determined by applying the equations, by applying our mathematical formulations of how reality works in a way to get an outcome that reflects the outcome of reality, right? And so one would say that with all of the information about a system, we are able to understand precisely and exactly how that system is propagating or permutating through time. The funny thing about quantum mechanics is that from our observations, what we've realized is that, or what we see, what we understand and how the math describes quantum mechanics, is that there is no determinability. There is no precise determinability of quantum mechanics. That's why we see the wave function. That's why we see the percentages of outcomes that are possible when we're talking about like where an electron is around an atom, right? We can't, so this kind of ties into the concept that you might have heard of where, you know, the more we know about the position of an electron, the less we know about the velocity of the electron and vice versa. And so what this is telling us is that even in a scenario where we have, or it's not necessarily telling us this, but the main takeaway is that what we're seeing, what we're observing, and what we formulated with our equations is stating that with the information about the system, we don't actually get, so let's say this is an atom and this is an electron, and we don't actually get a single determined outcome. We get several probable outcomes, right? And I think that this is the basic understanding. This is a very basic understanding that we should take from this. Now let's tie this into a popular kind of like metaphor or statement that is used to express this undeterminability. So in the equations, in the math that Schrödinger created, the way that this is kind of indicated is it's saying that there's multiple outcomes existing at once, and until the object or the particle is interacted with, or the wave is collapsing, all of those realities exist at once, right? And until one of the realities or the wave collapses into one of those realities, then the possibility of any of those realities existing is some percentage, right? And so we have like the box and the cat in the box, right? Schrödinger's cat. And the example here is that there's a cat that is both dead and alive. Let's see if I can draw a cat. So he is both dead and alive. This cat is dead, and this cat is alive. You can tell, not very easily, but we'll just indicate with some text. Let's get that a little bigger. And dead, right? And what we're saying is that before an observation occurs, the math, Schrödinger's equation, is stating that the cat is both alive and dead, and there's some probability that when we observe this box, or the contents of the box, the wave function collapses and the cat is either alive or dead, right? Now, when Schrödinger made this example, he was actually trying to point out the absurdity of what his equation was saying. because he didn't actually think that this is what was occurring. He thought that it was ridiculous, but that's what the observations, that's what, when you formulate the data that we've gotten from quantum mechanics, that's what it seems to be saying, right? And so from this, what we're really deriving and what I'm trying to point to, the main thing to take away is that there's this level of unpredictability, right? And the mechanism that allows the unpredictability, from what we can understand, is essentially this idea that there's two separate possibilities existing at once that then collapse down into the physical or tangible reality that we exist within now, right? So the wave collapsed down into a particle. And this is obviously a very layman description of quantum mechanics, and I'm sure any expert or anyone who's maybe got like a master's degree in quantum mechanics would be able to tear me a new one about how inaccurate this is. But I think, again, what I'm trying to get across here is like the main takeaways when we're discussing like the philosophical implications of quantum mechanics. And so the philosophical implication here is essentially that we can't necessarily make the assumption that there is a determinability of the universe from the human perspective. That is to say that if we have all of the information from the human perspective about a system, there's always an undeterminability of the outcomes of that situation. Now, I'm being very specific with my words here, where I'm saying human perspective, because in my mind, and I had an argument with a couple people about determinism and how it ties into quantum mechanics, where their argument was essentially that because of what I've just described here, quantum mechanics is indicating that there is not a deterministic underlying fundamental reality. There's an undeterminable fundamental reality, and that reality is not deterministic. There is some mechanism that is creating probabilities of outcomes at the lowest level or at a very low level, right? But I disagree with this, because from my understanding, what that would imply is that we have some kind of system, means that we have some black box, right? And we have X, you put it into the box, and there's some function that occurs, and then we get something out of the box, okay? And the outcome of Y, given that we know everything from some divine perspective about the box, the outcome of Y is not predictable, or there's some probability of some set of outcomes. Now, I disagree with the interpretation of quantum mechanics stating that this is the reality at some level, but I disagree with this. I disagree. Because in order for this to occur, what that means is that if we inspect the f of x box, if we inspect our black box in which we're putting some input in, or we have some system that is interacting in a particular way with the reality and then is getting outcomes that are unpredictable, it means that there is some piece or some function inside of our black box, inside of our function, that is creating outcomes that are unpredictable without any previous or parameterizing information about that mechanism. In this example here, I have described kind of a high-level function that has moving parts within it that are creating percentage outcomes, right? But what I'm trying to say is that within this function, there is this same kind of function, except it comes with no parameterization. That is to say that f of x is not actually defined in any particular way. So there's no definition of what f of x is, because if there is some definition about the outcome of the black box that we're describing, then that's necessarily deterministic. That is to say that because we have the information about that function, we know that the outcomes of that function are dependent on the information that we have. There is some information about reality given that function that we could use to predict, or to know, not just predict, but to know the outcome of that function. But to say that there is a unpredictability about the outcome of this function or the outcome of this system, and to me this doesn't make any sense, because if we have all of the information about a system, but we cannot predict the outcome of the system, then where does the unpredictability arise from? Because if we have all the information about the system and an outcome occurs that was outside of what our information was telling us could happen, then that necessarily means that we did not have information about the about the function or the system. So hopefully I've beaten that point down to the point where maybe it's starting to make a little bit of sense. But for me, it just seems that whatever mechanism that is, it one, either does not exist, or two, the mechanism that provides that unpredictability is outside what I think that we can really understand as humans. Now, maybe that sounds a bit dramatic. Maybe there's someone smarter than me who can understand that kind of mechanism, but I'm certain, I'm very certain, not 100%, but certain that this kind of mechanism does not exist within our reality. There's a contradiction. You can't have an outcome of a system from a divine perspective of all the information about the system be unpredictable. That just to me seems, it contradicts the hypothetical that I'm creating, essentially, right? When we look at quantum mechanics, what I see is an undeterminability from our perspective, an undeterminability that seems to imply some very interesting mechanisms occurring at a very, 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 very separate and incredibly complicated perspective about reality that we don't have the full grasp on. And I think I was saying at the beginning, or I was talking about kind of the multiple takeaways from quantum mechanics that we should have. And the first one that I presented here was the undeterminability of the quantum systems that we are observing, and kind of the implications of the math that has been derived from the data that we have about quantum mechanics. So the next thing that I want to talk about when we're talking about the philosophical implications is the spooky action at a distance. And what that is in quantum mechanics is entanglement. So basically, if you have a quantum particle and it has a spin, if it entangles with another particle, then regardless of the undeterminability of the outcome of that particle and its spin, once we have determined the spin of that particle based upon the observation which collapses the wave function into a particle, the entangled particle necessarily has corresponding information to that particle. There's a certain amount of interaction that is occurring across space and time between information that the human perspective doesn't necessarily have that we currently in science don't have an understanding of, or don't really know how or why that's happening. And what to me that points to would be a system that is operating outside of the kind of set of reality that we exist within. So I talked about this in an earlier video where there's like a layering of function. And we can describe the layering of function as an infinite stack, or it's possible that the layering of function is also a circular repeating pattern of function. But imagine the function endlessly upwards, endlessly downwards, and in this example, like incredibly, incredibly large. And each layer of function is essentially, every time you have some piece of information in the universe, the information by definition is doing something. There is some function of the information within the universe that causes it to do something. That's what gives it its kind of like tangibility, or its like reality of itself. And as a result of that, more function arises out of it as it interacts with information around it, and the function kind of like function is layering atop a function. And what I'm saying is that we are at a particular layer of this function, which gives us kind of this perspective about reality that we have, which is a very human perspective. And entanglement to us appears to exist outside of what we can currently explain or understand. Even Einstein was freaked out about entanglement because it implies some kind of spooky action at a distance which violates some of the laws of physics that we understand. I think it's, I don't know. I think that I'm butchering this part when it comes to the accuracy of what we currently know about it. But, again, layman's understanding of how this is operating. But what I would say is that there is some layer of function that is very, very, very far away from us. So let's say, like, let's get some dots here. Like, we'll go here, right? And so from this layer of function, I would say that we really don't have the capacity to access this layer of function in a meaningful way, right? Because I can't say that we can't access that layer, because I would say that from the highest perspective, all of the layers of the function are the exact same function occurring. It's just we are, from the human perspective, categorizing them as individuated from one another. But in reality, I don't think that there is any such thing as individuation. I'm a non-dualist, so I don't believe that there are separate constituent parts of the universe. I just believe it's all one infinite, expansive thing. I see entanglement as this thing that doesn't escape the capacity of the universe to operate in a particular way. I mean, obviously not. If we're observing that kind of effect, then it means that it's occurring in the universe in some way, right? But it exists simply outside of our context. It exists on a layer of function of the universe that to us, or to the so the brain is just like a physical object, right? And the brain is what is giving us the capacity or the information about the universe around it. And I would posit that it's most likely the case the brain can only be parameterized or permutated or constructed in a limited set of ways in order to provide an understanding of information about the universe. And outside of that limitation of what the brain is able to be constructed into, exists a lot of the functionality, or I would say the vast majority of functionality that exists within the universe, right? So our brain is kind of a computer that is built or capable of computing information about the reality that it's been kind of, that it has coalesced inside of, right? So it's kind of arrived or been created at this layer of function. And because of that, the information that the brain operates on and uses to create information about reality necessarily exists essentially on this layer of function, right? And so to try to explain or to try to understand or to try to conceptualize function layers that are so far away from what the brain is kind of constructed to understand or to inform itself about seems to me to be an impossible task. And in order to do that kind of information processing, one might need some kind of computational model that is separate from what the brain currently provides us. And I think that there's an interesting discussion here to be made about mathematics, because I think regardless of what we're talking about, whether we're talking about a brain or some other computational model that is taking information and then doing particular things with that information in order to provide some kind of prediction about things, or to in other words, saying understanding things, right? I think there is mathematical ways of determining, what kind of predictive models can we make, what kind of information systems can we have that allow anything to have understandings about how reality operates. So that is to say that it may be that there are layers of function out there that exist and operate within the framework of the universe, but the mathematical information model that provides a sense of experience about that function, or that is to say, that provides an understanding of that function, may not exist within the universe. Or it could be that we can prove mathematically that there are information models that we can have about the universe that describe everything contained within the universe. But from my understanding, it seems unlikely that that is the case. It seems more likely to me, based upon based upon my layman's understanding of some of the mathematical proofs that Turing did, some of the mathematical proofs that I can't remember his name, but it's like there are many proofs that are I can't remember what the word is, but they cannot be proven and they can't be disproven, but they exist nonetheless. And in my mind, that's really a statement about information, right? And how information can understand other information. And it appears to me from these mathematical understandings, and again, I'm a layman, so maybe this is a horrible interpretation that is completely inaccurate. It seems to me that there's some limitation about how information understands other information within the reality that we currently exist in at this level of function, right? And because of that, there is a limitation to what we could construct, such as a brain that allows an experience to interpret reality in a particular way, meaning that there are aspects of reality that, from the human perspective, from a brain's computational model perspective, can never predict the outcomes of a system. But that is not to say that we don't exist in a deterministic reality, or what I'm trying to say is that given a divine perspective about all of the information of a system, the outcomes necessarily follow from that information. There is no unpredictability about the outcome of a system given that divine perspective about all of the information about the system. Now, yeah, I mean, I don't know. This is just how I think about things. It's kind of how maybe some would say I'm coping in order to fit all of reality, all of our kind of mathematics and physics into my perspective so that it works properly. And maybe that's what I'm doing. But I would always say that I only believe what I believe because I really don't have a better model to describe what I'm seeing. And when I get a better model, then that's how I'm going to describe what I'm seeing. And so, if there's anything that seems here to be inaccurate or to be a large and huge misunderstanding of something that I'm trying to describe, then I am more than happy to hear why I'm wrong, because then I can more closely realize what is actually occurring. And I mean, that's what's interesting to me. That's just what I care about. I want to know, how are things really working? Like, what is the fundamental kind of machine that is creating whatever we're existing as? You might have heard the contradiction, right? So we're in a hypothetical where we have all of the information about the system, which means we have all of the information about how the system operates, about how it propagates, about how it changes, and about how, as time or space is differing or changing throughout the system, particular sets of information are permutating through the space or the time, right? In an undeterministic reality, even within the perspective of having infinite knowledge about the system, there is an unpredictability of the outcome of the system, right? So we have all of the information, but there is some information that we don't have.